All right, kids, it's time to talk about the four types of weather fronts that we're going to encounter as we move along through the next few slides. And if you look here at this slide, we've got four main weather fronts we're going to talk about: cold front, warm fronts, occluded fronts, and stationary fronts. Those are the four ones that we are going to cover. So let's go ahead and dive into those. Let's first look at a warm front. And it says here that a warm front is a boundary between two air masses. Obviously, it is. There's warm air and cold air. And it's the boundary between those two that we're really looking at. And what happens is warm air moves in and it replaces the colder air. Now, the things you got to think about that is how hot air and warm air interact when they're working against each other, especially as the two air masses are kind of coming together. We'll call it colliding. So let's take a look at what that looks like. Okay, here we have like a 3D representation of what it would look like if you have the different fronts. So let's watch what happens when a warm front comes in. You'll notice that the warm air is coming in. Now listen, this is not a shock. Warm air does not sink under cold air. What does warm air do? Well, it rises above cold air. Well, if you have warm, moist air rising, what do you think is going to happen? Exactly, they're going to have some clouds are going to form. So watch this. Notice that it's not moving super quickly. It's actually kind of a slow process as it moves along there. And you'll notice the type of clouds that it's building here. It almost looks similar to, like, say, stratus clouds, because it's not like a giant, massive storm that forms. It's this slow pushing, almost like you've got stratus clouds and a few days of rain that would occur when a warm front pushes in. So again, as we're looking at warm fronts, I really want you to notice this symbol for warm front. It is a red line. It has these little red humps on here. I like to think of that because it is moving a little slower, but it does point in the direction, so it's moving this way. It points in the direction of the movement, and again, like we said, it's going to bring some of those days of light, steady rain. If it happened to be in the wintertime, yes, I know a warm front actually can move in the wintertime. It sounds odd, but if it did, you might have days of light snow. Again, warm front means that there's a warmer air mass moving in the direction. It points in the directions of these circles, and it's moving in on a cold air mass. And they're going to collide. It's going to bring precipitation where the warm front is approaching. So if we're looking at a weather map, and we've done this before, except we can go back and do it again, and we're actually drawing these shapes on there now. Now we know that a warm front moving into an area means that it's going to have showers, but not super strong showers. Well, if there's such thing as a warm front, it's no shock that there's a such thing as a cold front. And a cold front is where a cold air mass moves in. And you'll notice here that it says it moves in under a warm air mass. And it moves in a lot faster than that slow-moving warm front that we saw. And we need to think about that. If a cold front moves in very fast and very quickly pushes up that warm air, we're going to have a lot of evaporation and condensation happening at one time. And we're going to see that there's a little bit of a difference in the type of weather and precipitation that might occur when a cold front moves in. The first thing that I really want you to notice is how much faster the cold front seems to move in. And we know that cold air sinks. Hot air is going to rise. And this cold air is going to sink super quickly in this diagonal fashion, like really quickly under the warm air, and push it up pretty rapidly. And we see this a lot in the summer. And you've seen this. You've been outside on a summer day. It's hot, it's muggy, it's that humid day that we've talked about. And then all of a sudden, it starts to get very, very cool. But it's right at about the same time that you start to hear thunder and the storm is moving in. Because when we have a cold front move in, it just produces such an undercutting of cold air, and it pushes all that warm, moist air up so quickly, as we'll watch right here, that it makes the warm air go up and it condenses into clouds, and these clouds turn into storm clouds. And when you have a cold front move in, you're going to notice these clouds are a lot different. Look at these clouds over here building up. Notice how it's going way, way up. We're talking cloud 9 here. We're talking the cumulonimbus cloud, which can produce very, very heavy rain and oftentimes some pretty intense storms. Again, I want to point out, notice the icon for a cold front. We've seen those before. We saw them when we were working on our weather maps, and we have like these little jagged teeth. And if we look back at this, we can see why it has that jagged tooth look, because it really does kind of slice in up under the warm air mass that's sitting there. So what happens is, and you know that they're pointing in the direction that they move, they push down and under so quickly, because it causes the hot air to rise and condense so fast that it brings along with it some heavier storms and oftentimes thunderstorms. All right, if you're following along on the Nearpod, you're going to realize, hey, Mr. Bowens, you skipped a couple of slides. I did, because I want to hold off on Occluded Front until the very end. I think it's the most difficult of the 4 fronts that we're going to talk about. And we're going to talk about a stationary front. Now, the first thing I want to talk about when I say stationary front is we've all seen the football player that gets cramps and he has to go on the sidelines and ride the stationary bike. Does he go anywhere? No, he's stationary. He stays in the same spot. And that's really what happens with a stationary front. Go ahead and take a look at the picture here. And what do you think is happening? I've got 2 air masses now, and 2 fronts that are kind of colliding with each other. And let's take a look at what happens when you have 2 air masses colliding and coming straight at each other. All right, so here you can see I've got my cold air mass here, my warm air mass here, 2 fronts. But instead of one coming behind the other and kind of chasing it, they're coming together and they're going to kind of hit in almost like a collision. So let's watch what happens when these 2 are pushing against each other. So you'll see the cool air coming this way, the warm air coming this way, and very, very slowly as they kind of push. See how they're pushing back and forth? And in between these 2, because warm air is still going to rise, that humid air is still going to rise, when you have a stationary front, you're going to have weather that stays with you for a while. So that might be those days when it's raining and raining and raining, because the 2 fronts are stationary. They're not moving very far. Now, when we look at that on a map, you're going to see them. It really is moving a larger distance than you think. But those clouds are so enormous and there's so much precipitation falling that you'll notice, again, like I said, they just don't seem to move. Watch them pushing each other. It's almost like back when we had our equal and opposite forces, balanced and unbalanced. This is almost balanced. They're just barely pushing each other, not enough to move one another out of the way. So it's like balanced forces. Not a lot of movement, but a whole lot of rain is happening in this situation. So let's go back, and again, we've been talking about the different symbols that we would see with a cold front and a warm front, and you'll notice I have the 2 fronts colliding because the warm front, you can tell, is moving this way. The cold front, based on the diagonal part, is moving this way. So I've got my jagged edges of the cold front moving this way, the warm front moving this way, and you can see that they're not moving a lot. They're not moving a lot. And again, when you have those stationary fronts, you're going to have those days, 2 or 3, 4 or 5 days of long periods of rain where it just never seems like it's going to go away. All right, last we're going to talk about our occluded front, the occluded front. Now what's happening here is I have this warm front here, and remember they're kind of slow moving, and I have this cool front in behind it, and it actually kind of catches up and overtakes the warm front. And again, if you were to mix, red and blue, you would get purple. And that's why you see the symbol for the occluded front has the same triangular shape of the cold front and the same little humps of the red front, but it's in purple. Because now what you've had happen is you've had a cold front overtake a warm front. So let's take a look at what that looks like in our 3D model. All right, so you'll see we have our warm air here. It's trapped behind this because remember it's a warm front, and to have a warm front, it's supposed to be pushing cold air out of the way. And so let's watch what happens when this cold front catches this warm front. Again, it sinks up under here. Now what that's doing is it's pushing all of that warm air up into the air. And you're getting a lot, massive amounts of condensation going on. And again, look at the type of clouds that are forming here. Does those look like stratus clouds? No, they're not blanketing the sky. This looks like it could be more of a heavier rainstorm, even like thunderstorms when you have an occluded front moving in, and that would be correct. You can have some very dangerous thunderstorms when occluded fronts move in, because what you're getting is you have a ton of hot air being pushed up at one time with a lot of moisture in it, and that combination of hot air being pushed up very quickly and cool air with that downdraft, you can obviously have some pretty intense storms going on. So let's take a look at the occluded front a little bit closer. Picking back up here, I know this is a long video, and for that I apologize, but here's our last slide about the occluded front, and then you can go back to the Nearpod codes and watch the videos attached with this. Again, notice that the cold front is catching up with the warm front, and when they hit each other and they mix, you're going to get this purple color. So if you were drawing it on a map, again, if you had your weather map and you were drawing on a map, you would use the blue with the triangles for cold front, the red with the humps on it for warm front. You would have, if we went back and looked at our other one here, you would have, my goodness gracious, there's a lot of slides. Cold front, I went the wrong way because I forgot I skipped that. Here we go. Here's what you would have for stationary front, because you would have them going in opposite directions. And then lastly, if we look at our occluded front, you're going to have this purple color here. And you can draw this part down here, but I will know what you mean if you just put a purple on there and it has both parts of both symbols mixed in with it. You would have your occluded front. Again, feel free to leave any questions only onto the Google Classroom so that I can find them and answer them. I know some people have had some questions, and again, it's really hard for me to find those when people have like 18 million comments in there. Try to keep that down as much as you can so that I can find the questions that people have. And I'm looking forward to talking to you and seeing you again soon here online.